Databases are defined as an organized collection of data stored and accessed from a computer system. They support storage and manipulation of data, and we loosely refer to databases as the collection of data and the associated software. Sometimes people refer to a database as the actual data, and sometimes they'll refer to it as just the software. In this context, we're going to refer to it as both the collection of data and the associated software. Now, there are a number of database types out there. The most common database type is a relational database, in which the data is arranged in rows and columns in relatable tables. And that's what we're going to focus on today. But there are all kinds of data types out there, and depending on the application, might be a better choice for managing your data, including object-oriented databases, in which the data is organized as objects with attributes that are related to other objects. NoSQL, in which the data is denormalized. So we're not worried about repetitive values and really large flat files because we have computing systems that can handle very large and fast performance. Graph databases organize data as nodes and edges. So it's more about the topology and the connectivity between the objects than the objects themselves. Cloud databases are distributed databases accessible via the internet. It's really nice to have cloud databases. One, you can spin them up very cheaply. Two, they're very easy to replicate so that you can maintain data integrity. If one system goes down, you can bring up another, and you can scale them up and down very easily. Self-driving databases are autonomous databases that use machine learning to automate administration and maintenance. So rather than hiring a database administrator to manage your data, you use a self-driving in which machine learning administers the database. Lastly, federated databases are single metadatabases that provide uniform access to multiple autonomous databases. You can imagine a very large organization that has an HR database, they have a products database, they have a marketing database, they have an accounting database. And the leadership needs access to all those databases. So they'll create a federated database that doesn't take all the data and then try and store it in the federated database. It just maintains access to all those different databases and allows you to query across multiple systems. A database schema is the organization and structure of a database. It defines how database objects, attributes, and relationships are structured. It includes the definitions for tables or entity sets, fields or attributes, keys or unique IDs, and relationships. Schema are often synonymous with data model, but the data model is the plan, the conceptual, logical, or physical data model. The schema is the actual implementation. It's actually creating the structure within the physical data model. Sometimes we refer to the schema also as a data dictionary because it's a single reference that describes how the data is structured. A database management system, or DBMS, is a software that controls the creation, maintenance, and use of a database. It's the interface between the database and its end users or programs, and it supports the data storage, retrieval, and update, as well as oversight and control. A database management system provides these functions: local organization, controls access, enforces data integrity, manages concurrency, facilitates access, and allows for rollbacks, which is simply to undo. Here are the components of a database management system, including the data definition language, data dictionary, data update module, data entry module, query language, and report generator. The data definition language is just the structure that allows us to create a new database and tables with attributes. The data dictionary is the list of attributes for a table along with their legal values and ranges. So it's the attribute names and whether, for example, it's a number or a text. The data update module allows us to modify the data dictionary or schema so that we can change the name of a field or change the type of data that's stored in a field. The data entry module allows us to enter and modify individual values that are stored in our tabular data model. The query language allows us to submit a question to the database and create a new view where instead of having 1,000,000 records, I can send a query that queries out maybe 1,000 records that I'm interested in. Last, the report generator is a way to produce a listing of all or a subset of values stored in a database table. This is the actual hard copy report that you take to the meeting and explain to leadership what's going on with your data. A relational database management system is a DBMS based on the relational model. In a relational database management system, the tables are related to each other by a common key field. This enables a flexible structure that allows multiple views of the same data. It's much more efficient than a flat file because duplicate values are normalized into separate related tables. And we'll talk more about that in just a minute. Examples of relational database management systems include Microsoft Access, Microsoft SQL Server, Oracle, MySQL, and in some ways, even ArcGIS is a database management system based on the relational model.